The next couple pages here just talk about converting back and forth. So the first example is converting from polar coordinates to rectangular coordinates. So if they give us polar coordinates, r is this distance here, and theta is our angle here. What they want us to change it to is rectangular coordinates. So we need to find x and we need to find y. And I'm trying to give you the very visual way of why the formulas are what they're going to be in a second. So when we're looking at this, if I wanted to find x right now, I would have to use cosine. It'd be cosine of theta is equal to x over r. And if we solve that for x, this is going to be our formula, x times cosine of theta. But again, I'm not one to memorize formulas, so if you needed to, you could draw out the triangle every time and figure it out that way. But it's a pretty simple formula if you could memorize it. To find y, we'd have to use sine. Sine theta is going to be y over r. And then again, to solve for y, we would multiply by r, so the formula is y is equal to sine r times sine theta. So those are our two formulas to change to polar coordinates. So in example number 1, if I want to change this to polar coordinate, or from polar coordinates to rectangular coordinates, I'm going to start by using the formula for x. That's going to be the r value times, actually I'll write it out. It's going to be r times cosine theta. So x is going to be 4 times cosine of pi over 3. And now this part you will need your plate for, is this, you need to know this value, as you can use your plate to find that value. And that is really 4 times cosine of pi over 3 is 1/2. So that's going to give us that the x coordinate is really just 2. Then we need to find the y coordinate, so that's going to be r times sine theta, which is 4 times the sine of pi over 3. And then again, we're going to use our plate to evaluate the sine of pi over 3. I don't want you to use your calculators for these because they're on your plate. You'll get a more accurate answer, so I want the exact value. This one's radical 3 over 2. And then if we simplify that, the 4 and the 2 will cancel. We'll get 2 radical 3. So our final answer would be just to write out what the point is. That point is 2 comma 2 radical 3. That's our final answer here. So let's try a couple more. There's some variations on the next page. So for number 2, it's the same formula. If I want to find x, x is going to be r, which is negative radical 3, times the cosine of pi over 3. So that's going to be x is equal to negative 3. We just found cosine of pi over 3, that's 1/2. But this time x will come out as a fraction, negative radical 3 over 2. And then to find y, it's going to be negative radical 3 times the sine of theta, which is pi over 3. And we just figured out that that is, whoops, not sine anymore. It is radical 3 over 2. So this was just to show you, remember if you do radical 3 times radical 3, that's really just 3. So this comes out without the radical, negative 3/2. So our point in rectangular form would go over negative radical 3/2 and down negative 3 over 2. Alright, and the third one, if I want to find x, x is going to be 2 times the cosine of pi. And cosine of pi is negative 1. So the x coordinate is going to be negative 2. And then to find the y coordinate, we're using the 2 times the sine of pi. And with this one, sine of pi is actually 0, so we get y equals 0. So the coordinate is over negative 2 up 0. And if you were to think of where this is going to graph, this is going to graph on the pi part, just to connect this over why this really is the answer. This would graph on the over here at pi, and it would be 2 out, so it is going to be over negative 2 up 0. Alright, the last one has decimals in it. So this one you'll have to use your calculator, and your calculator needs to be in radian mode. So if you make sure to go change it, because it's probably in degree mode right now, To change it, remember you go to the home screen. It's number 5, number 4, and please, 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 please make sure you hit make default or it won't change it. So you have to do that for it to change it for the whole problem. All right, so now if I want to find x, it's going to be 2 times the cosine of 2.74. That's just the radian measurement of an angle. So you're just going to type that in your calculator to get your answer. And we get negative 1.84. If you didn't get that, double check to make sure that you're in radians. It should say rad up in the top right corner. And then to get the y coordinate, it's 2 times the sine of 2.74. So we type that in the calculator and we get 0.78. So those two go together to create our coordinate, negative 1.84, comma 0.78. Okay? Now we're going to change the other way. So on this one, we are trying to change from rectangular form to polar form. So when they give you rectangular form, they're going to give you the x, and they're going to give you the y. And what we're looking for is we're looking for r. So first off, to think about the formula for that, if you just look at that for a second, that's a right triangle. So if I wanted to find r, it's the missing side of the right triangle, you'd use Pythagorean theorem. So to find r, we'd do r squared is equal to x squared plus y squared. And then to find the angle, that's here right now, to find theta, if you look at, we would have x and y, so x is the opposite side, y is the adjacent side, we're going to use tangent. Tangent of theta is equal to y over x is our formula to find theta. So those formulas are actually going to pop up in the next part of the lesson as well, so those end up being really, really important formulas. So we're going to convert these now, and for these, what you have to be careful about is anytime there's a negative, you're going to have to look in a different part of your plate. You're going to have to look in a different quadrant in your plate. So for these, because they're in rectangular form, I try to at least give a little sketch. So this current point is over negative 2 up 2. So I know we're in the second quadrant. That's going to pop up in a second. This also, if you really didn't remember the formulas, you could draw this and you'd be able to find r and theta pretty easily from just drawing the triangle in the picture. But I'm going to use the formula. So if I want to find r squared is going to equal negative 2 squared plus 2 squared. It's just Pythagorean theorem. R squared is equal to 4 plus 4. R squared equals 8, and we're going to take the square root, and we are going to do these as simplified radicals. So r is going to equal 2 radical 2. So that's the first part of the polar coordinate. The second part is we got to find theta. So theta would be our angle here. So we're going to do tangent of theta equals the y value over the x value. So the y value is 2, the x value is negative 2. So we get tangent of theta equals negative 1. And then you're going to look on your plate to figure out where tangent is equal to negative 1 so that you can get the answer to this. Because right now, technically, what we're doing is we're doing arctan. Arctan of negative 1. But negative 1 is on your plate, so you're just going to look on your plate in the correct quadrant. You do have to look in quadrant 2 because I know that's where the rectangular graph lands. So I have to pick an angle that's in that same quadrant. So that should be 3 pi over 4. So then our answer is to put those two things together, as I know my polar coordinate is 2 radical 2, comma 3 pi over 4. That would land on the same place as our rectangular quadrant, or a rectangular coordinate. Let's try a couple more. So in number 2, if we want to find r, it's again just a formula here. R squared is equal to negative 2 radical 3 squared plus 2 squared. When you square this part, you do have to make sure you distribute the squared. So that's 4, negative 2 squared is 4, radical 3 squared is 3. So 4 times 3 is 12. Plus 2 squared is 4. So we get r squared. If I add those together is 16, and then we have to take the square root. So r is equal to 4. And then to find theta, we're going to use tangent. Tangent of theta is equal to, watch your order here, it has to be y over x. So we get 2 over negative radical 3, which tells me tangent theta is equal to, if I simplify, negative 1 over radical 3. And you do have to rationalize to be able to see this on the plate, so you can't leave your answer like that. Tangent of theta is equal to negative radical 3 over 3. And then we need to look on the plate to find theta. Again, you need to make sure you're looking in the right quadrant. So I didn't draw this out yet, but let's go back and draw it out. That's going to be over negative 2 up 2. That's also in the second quadrant. So we should be looking in the second quadrant to answer this one. And that one's going to be an answer of 5 pi over 6. So those two together will give me the polar coordinate of 4, 5 pi over 6. So that's my answer for number 2. Number 3, we can use the same formula. R squared is equal to 0 squared plus negative 4 squared. R squared then is just equal to 16 because the 0 is going to drop out, and the radius is going to be 4. And then we have to find theta, so we're going to use tangent. Tangent of theta is equal to y over x, so you get negative 4 over 0. And that tells me tangent theta is equal to, since 0 is on the bottom, undefined. So I need to look at where it's undefined, again specifically in the location of where 0, negative 4 is. So that's over 0, down negative 4. So you should be looking on the bottom part of the plate, and that's going to be, that section is 3 pi over 2. So those two together give me our polar coordinate is 4, 3 pi over 2. Alright, the last one, if I want to find r, hopefully this looks really easy to find r right now. 5 squared and 12 squared, I think some of you already would know what that is. If I add those together, that's 169. Take the square root, I get r is equal to 13. But if I want to find theta, tangent of theta is going to be y over x, 12 over 5. That is not on your plate. So when you end up with a value that's not on the plate, you're going to have to use your calculator. If it's on the plate, I want you to use the plate. But if it's off the plate, you're going to use your calculator, and you're going to use arctan, since that's what we would use to get theta by itself. So we're going to do arctan on the calculator of 12 over 5, and that will tell me what this angle is. Again, make sure you're in radian mode so you get the right answer. It should come out as a decimal, not as something that looks like a degree answer. So this is 1.18. And then we put those together to get our polar coordinate. Our polar coordinate is 13, 1.18. Alright, so that's all for day 1. So try the homework, see how it goes. And then I will get you guys the answers once you've worked through it, and we'll see how everything's going here. We've got a day 2 assignment and a day 2 notes, and then we did a class kick on Friday.